are tools to build and fix things around the places that we live. And we easily have, many of these tools. Software engineers also obviously rely on tools to build and fix the software that they build. So it's hard to imagine, the days when we didn't have search tools and compilers and debuggers and integrated development environments to build things. If you go through the conference proceedings of any of our conferences, they're really filled with ideas about what kind of new tools could we introduce to build software better. But, if you've been around as long as I have, you start to realize that very few of these tools actually make it from idea into production and use. So maybe that's just the way things are meant to be, that interesting research tools remain unused and they're only described in papers. But I'm really interested in whether or not there's steps that we can take to increase the likelihood that the tools we propose in research could actually make it into use in industrial practice. So this talk is about exploring some of those ideas. And I wanted to start by looking at what it means to have usable and useful tools. And that really means that we have to think about the difference between what usable is and useful is. So if we start to try to get a sense of these terms, one way I find it useful is to think about physical objects and what does usable and useful mean in the context of physical objects before we talk about software tools. So you see two door handles on the screen. I would contest that both of them are useful. They can both be used to open a door. But there's a question about which one's actually more usable. So the one on the left typically takes a lot more dexterity to grasp and turn the knob to be able to open the door, whereas the one on the right just requires like an up and down motion. So many might consider the one on the right to be more usable because it can be used in more contexts. And in fact, in Vancouver, where I live, they started requiring these levered door handles in 2014 because it helps accommodate more people with a range of different kinds of abilities. So if you don't have as much dexterity to grasp or you're maybe elderly, you can still usually use a levered door. And during a pandemic that we've been in, I think we've also grown to kind of like these doors at times because you can use your elbow and you don't have to actually touch the door with a hand. So in terms of a door, we can start thinking about usable and useful a little bit. And in the case of software, it starts to get a little bit more difficult, but there's still things that we can start to reflect on about these two terms. So here's two tools that you might consider useful, which are search and comparing files. But you might ask yourself whether or not these are actually usable tools. How much do you actually have to know to start to use them in a way that is very self-evident? And what I'm going to contend is that there's often too much of a gap between what developers need and the tools that we provide. So while you certainly need to search code and understand the differences between two files, sometimes those tools are not actually designed in a way that makes it easy to use them for the tasks that you're doing. So what if we paid more attention to usability and usefulness of software tools? Could that actually allow us to bridge the gap between the developer's needs and the tools that we're going to provide them? So here's where we're going to end up at the end of this talk. I want to show you that if we actually pay some attention to the usability and usefulness of software tools, we can do that by studying those tools in the context of use. And the understanding that we gain through that study will lead us to, in fact, impactful research results in and of itself. But when we get it right, we can use that information we learned from the study to provide more likelihood that the tools we build will actually see large-scale use, not an eventuality that will be true, but an increased likelihood. So I really want to convince you that the study of the context of use of tools is really worthwhile. And in fact, it's actually time for us in the research community to stop just proposing new tools and see how we can move more of these tools into practice. And I'm going to show you a couple of ways that we might do that. So here's a roadmap for the talk. I want to kind of walk through this potential way of doing this using two particular pieces of work as an example. First of all, I want to talk about kind of the first part of this pipeline of identifying a problem, proposing a tool, considering usage context, and building it. in the context of work that Anna Ellertson's been doing as part of her PhD at the University of Bergen. And I've had the joy of working with Anna on this project. And then second of all, I want to talk a little bit about how when you actually start then taking a tool that you've built and studying it in the context of use and thinking about deploying it in sort of actual practice, that you can learn a lot more about what it might then take to make it to large scale use. And I'll talk about that in the context of the work that I've done with Mick in building up TaskTop through, first of all, Mylan as an open source system. So let's start with the first part, a case study of looking at refactoring tools. And this is the joint work with Anna. So if you think back to the roadmap I showed you, the very first part of the roadmap was you have to actually identify the problem that you're trying to solve with a tool. And so I'm going to go all the way back to one of the first people who looked at refactoring, who happens to be also a colleague of Harold and I's and others, Bill Griswold, who's at the University of California, San Diego. And when Bill was doing his PhD at the University of Washington, he introduced this idea of automated refactoring at about the same time that was done by Bill Opdyke. And in his thesis, Bill makes this statement, Bill Griswold: maintenance tends to degrade the structure of software, ultimately making maintenance more costly. At times, then, it's worthwhile to manipulate the structure of a system to make those changes easier. However, it's shown that manual restructuring is error-prone and expensive, and this was the motivation for building automated refactoring tools. So really nice, crisp identification of the problem at hand. And so using that as a motivation, people started building these automated refactoring tools that we now really take for granted. There was a bunch of really early proof of concept tools back in the early 1900s. Martin Fowler came along and talked about refactorings in his book, which really popularized the idea of refactorings. And then you saw a lot of work about implementing refactorings into integrated development environments in particular. So we have a lot that are very popular, like rename method, and then we have some that are a little bit more sophisticated, things like inline and other kinds of refactorings. And in most of the common IDEs in use today, there's 40 automated refactorings at least that are implemented in those toolkits. So in this case, we had a crisp identification of a problem. People proposed a tool. But what I'm going to show you is that they skipped a step. They didn't actually go and consider how those tools would be used in context. They actually went right to building the tool, deploying it, and see if it could get used. And this has led to some problems. So if you look in the literature, there are a ton of studies, I've just highlighted 4 on the screen right now, that show that there are a lot of problems with automated refactoring tools. And now it's pretty common to study the disuse of refactoring tools. In fact, study after study has shown that more than 50% of developers still refactor manually instead of using these tools. And so this seems to be a place where we kind of missed it, right? We missed giving people tools that they actually want to use. And as a result, refactoring tools are underutilized. They're there, they're ready to be used by people, but developers are actively choosing not to use these tools. So you might ask, why are they not being used? And it turns out there's a whole host of categories of problems that have been learned through various kinds of studies. So there's been lots of hypotheses and reasons about why these tools aren't used, ranging from a lack of awareness to an inability with the actual interface to, let's say, select the code that you need to have identified in order to apply the refactoring. There's problems with predictability of what the tools will do. People don't trust the tools. So a whole host of reasons. And despite the fact that we've been studying this since 2012, we really haven't seen any changes to the refactoring tools themselves. And so if you think back to my analogy of actual physical tools you might have around your house, like a hammer, it's like we have these refactoring tools sitting around in a tool chest just gathering dust. We keep maintaining them, and yet nobody is actually really using them in earnest. So why is that? Well, I think it's because they missed the step, right? They missed considering this context of use. So what do I mean by the context of use or the usage context? Well, let's go back to the door handle. If you think about studying the context of use, I want to walk through these two scenarios of using a door handle. If you think about the first scenario, when you actually are already studying the door handle after you've grasped it, and as you're about to turn it, that's kind of like studying tool invocation, the moment in which you've decided you're going to use rename method and you're invoking it. And when you study a tool at that moment of invocation, that can really help improve usability. You might learn, as people have, about how you could make it easier to identify the code that you want to rename or identify the code you want to inline, but you're kind of limited in terms of how you're improving the usability of that tool, because you've already gotten someone to the point where you've said, here's the tool, try and use it. Just like with this door handle, somebody's already had the ability to grab. You're not actually looking at all the people who might not be able to grab the doorknob. Think about what often happens as you come up to a door, especially maybe, around the holiday season when we tend to buy a little bit more. You've often got stuff in your hands, right? And if you've got stuff in your hands, then we all know what happens if you had the round doorknob. You kind of like put the packages over on one shoulder and you try to get a hand free. It's really bad when you're holding a kid or something, and you might drop the child. If you have a levered door handle in this situation, it actually gets to be a lot easier because you can actually use your elbow while still holding the things to open the door. And so I contend that when you start to look at this bigger context, the kinds of tools you might build and what they look like start to change. And so if you look at that context of somebody actually walking up to the door in a scenario, you're starting to consider a little bit more about the interaction between usability and usefulness. And now I'm not clicking for it. There we go. So what Anna did is she kind of went back and said, what would it look like if we actually studied refactoring tools during actual software change tasks, instead of just the invocation of use? Then we might learn a lot more about what these tools should look like. So she found 3 tasks in old systems that had been done as changes to actual systems that had been identified by refactoring mining tools as including refactorings. She then recreated a part of Apache Commons Lang to make something understandable that people could walk up to and have to do these particular tasks on. One task had to do about organizing test methods, one had to do about removing redundant methods, and one had to do about removing some overloaded method functionality. So it was known that a refactoring had been applied in these tasks, but the tasks were not about refactoring per se. She then recruited 17 professional developers to participate in an experiment. They had an average of about 10 years of experience. The applicable refactorings that applied to each task, there were multiple. So for the first task, it would be kind of natural to use move method or extract class. For the second one, it was really about inline method. And the third one was about safe delete, inline method, and remove parameter. So we weren't expecting people to use any or all of these refactorings. We really wanted to see what happened as they started to work on the tasks. Each participant spent about 1.5 hours working on the tasks. And between each task, there was a little bit of a debrief interview that happened and some discussion about, you tried the refactoring X and you gave up, or why didn't you try refactoring Y? So it's not like the participants were completely oblivious to the fact that refactorings could be used on these tasks. We ended up with about 32 hours of video that we transcribed to 13,000 words or so. So there was a lot of rich data to start to analyze. So it was really interesting to see what developers used as tools when they approached these tasks. They used things that you might expect, like textual search. They used the compiler output, right? What if I remove this parameter I'm supposed to remove? What are the error messages? And I'll navigate through the error messages. They used structural navigation, which we know is often used by developers. They use diffs from Git a lot, which we didn't expect. So they would change the code, go, man, this is not going the way that I wanted it to go. They would do a diff against the original code and sometimes then restart because they didn't like the direction of the task. And sometimes they actually also used refactoring tools, which was helpful to us because that's what we really wanted to study. Now we took all of this analysis of the 32 hours of video and we broke down the information in multiple ways. One of the aspects we were interested in was to understand kind of the workflow and how people were approaching the change tasks. And through analysis of the kinds of approaches that they used in looking at the code and working through the code, we were able to come up with 3 categories of strategies that they used to approach these refactoring tasks or these change tasks. Some people did a very local strategy, which tended to be guided by compiler feedback. Let me change the code in this precise place. What are the impacts? Let me now go and fix the impacts. Let me go change it. And so in a very local way, they considered the change tasks they were doing. Other people were very structure oriented. They would do much more structural navigation and do a bit of planning about what they wanted to change. And then they would go in and they would actually start to do the actual code changes. And other people were what we call an execute strategy. They were insistent on keeping the code running at all times, and they relied on the test suite to a great extent. So they might make a change, see if the test suite still ran, make a change, see if the test suite still ran. And as soon as it didn't, they would back off and then do more planning and move forward. Now, what was kind of interesting as you start to think about those categories of strategies is that people had sometimes a predominant strategy. So this little graph shows you for each participant in columns, what strategy they dominantly use for each task. So P2 on the far left was a local strategy person, and they use local strategy for every task. Whereas, let's say P4, which is 3 columns from the left, they used a structure approach for task 2 and 3, but a local approach for task 1. And so you can see a couple of things from this chart. If you look over any row, there was no dominant strategy for any of the tasks. People used all sorts of different strategies. And the second thing you can see is that some people, while they had a dominant strategy, not everybody always used the same strategy. And so this is going to be interesting as we see, because that actually affects the kinds of tools that they might be prone to use. So I'm going to zoom in on each of these charts in different ways to drive home the point that refactoring tool usage, because I want to hone in on that now, actually dropped from the point when they were considering the tool to be used to actually using it. And that is actually impacted by the kinds of strategies that they were taking. So this particular chart kind of shows you 3 groupings of tasks on the x-axis, and it shows you all the participants in each row. If there's an A, it shows that they were aware of a refactoring tool. If it shows a T for a task, it shows that they tried it. And if it shows a U, it shows that they used it. And it's pretty easy to see from here on task 1, there was a lot better capability in general to go from awareness to trying a tool, refactoring tool, to using it. Task 2, not so good. And task 3, kind of back to task 1. So the tasks had different kinds of characteristics, which is good. What's interesting is that there is a drop-off, right? People knew that they could use a refactoring tool. In fact, most participants did at least once know they could use one. Some of them tried it, but not very many of them actually used refactoring tools successfully. If we look at it from another point of view in terms of the strategies that those participants were using and how many tried refactoring tools, were able to use them or actually use them, you can see that there's drop-offs. So here are people that take a local strategy, that kind of compiler output driven individual. You can see that they were aware of refactoring tools for each task. They tried them and, not that much success in actually using them. If you look at the blue particular lines, you see that there's a little bit more success in going from awareness to trying to using. And we could hypothesize that these structurally oriented people had more of a plan of what was going to happen with the code when they actually invoked the refactoring tool. And so perhaps they had more trust and predictability of the code that they were actually going to see as a result of using the tool. But that strategy, the context of use, actually does really impact how people walk up and use tools. So when we analyzed a lot of what we talked about with the individuals in terms of why they ended up not using refactoring tools, there was really two dominant themes. One was that they had a lot of difficulty in controlling the impact of what the refactoring tool would do. So let me give you a case of somebody doing an execute strategy. These are people who want to keep the test suite running, and they're doing a particular refactoring. The refactoring changes the test suite. And now they're starting to get a little concerned because they're not sure whether that change in the test code is actually representative of the functional behavior that they want the code to keep having. Logically, if we think what a refactoring is doing, it should be, but they started to gain more concern. They wanted to separate their code and say, I'm willing to apply the refactoring to my kind of main code, but don't touch my test suite because I want to deal with that separately. The refactoring tools don't make that easy to do. And so they started to back off using the refactoring tools. Another thing was a loss of knowledge of what the code would be after applying the refactoring tool. So if you're a person who liked the really local strategy, you like the line by line change. So you know what was happening to the code. And when you apply a refactoring tool, one of its advantages is it changes things all over the place. And they felt very uncomfortable with then not knowing what happened to the code. And after they applied the refactoring, the only thing they really had was Git diffs to go through and understand the impact of the change. So that made them back off from using the tool. What I'm going to try to argue in a little bit is that these are things that are easy to change. And so we can actually probably make those tools more usable. We were also interested in kind of this, in trying to get a little bit more structure around what usability means and be able to analyze the usability of code in a much more specific way. So we went back to the definition of usability that comes from ISO, that talks about the extent to which a system, a product, or a service can be used by specified users to achieve specified goals with effectiveness, efficiency, and satisfaction in a specified context of use. That's what's on the definition on the left hand. Problem is, like, what does that mean? You know, what is effectiveness? What's efficiency? What's satisfaction for a software tool? So we took that definition and we said, okay, based on what we learned from the study we just conducted, what if we tailored this definition for a theory of what we think usability is for refactoring tools? So we did that, and you can see that we started to define what effective means, that it might mean locating and applying in a reasonable amount of time for a desired intent. And we started defining what efficiency was and what satisfying was. And then we went back to our study transcripts and we said, what if we analyze these transcripts now thinking about this definition? So we went through every line of the transcript and we tried to identify when one of these kind of fuzzy characteristics that we tried to make more specific had actually been referred to by a participant. So you can see some examples of this on the screen. In one row for participant 4, the very first one at the top of the left, the participant says, okay, I'm kind of surprised. I'm kind of shocked at what's happening here. And we coded that as being not predictable for the tool. So we tried to go through this and do this in a systematic way. We had 2 people do this coding so we could start to get a handle on kind of what aspects of usability had our participants been referring to. So these are the 5 codes we used. We looked at effectiveness, efficiency, satisfaction, which come from that ISO definition. And then we considered 2 aspects that had come out of all those studies of refactoring tool disuse that have been published, which are about trust and predictability, because those seem to be very important characteristics. So what did we learn? Well, we looked at all the tags that we did over these 13,000 words of transcripts, and applied association rule mining as a way to kind of try to understand if people talked about any of these aspects together. What was interesting to us is that the most commonly uttered characteristic of usability was predictability. So a lot of our participants commented very frequently on not knowing if a tool was going to be predictable or requiring the tool to be predictable, both the positive and the negative sense. Way down on the list was actually trust. So if you looked at all these previous studies, they said trust is the most important thing. At least when we studied these 17 people in depth, trust was not such a big thing for them. And we didn't see lots of aspects of usability coming up at the same time. So sometimes people talked about predictability and satisfaction together, sometimes predictability and effectiveness. But for instance, trust was very rarely talked about with any other particular characteristic. Now, when you do this kind of study of only 17 people, you get one sense of how usability might matter, but you'd actually like to know if this holds within a broader kind of population. So we put a study out there on the internet. We managed to get 46 in-depth respondents for some fairly lengthy survey questions. And what we did is we took all the tools that had been used by our developers in our study where we watched them and videotaped them. And we then asked this broader population, which of these tools do you use frequently? And then went on to give them some scenarios about refactoring, to ask them about their when they would choose to use refactoring tools and what they would expect from their tools. And you can see here that again, diffs are a really important tool. That is the next one I would want to study in depth because people really care about diffs. Again, it's not clear whether they're actually that usable. You can see that even 67% talked about using what we called complex refactorings like inline. So we know that at least people were aware in general of these kinds of refactoring tools. What I think is interesting that came out of this particular survey is we asked them about the trade-offs of these usability characteristics of effectiveness, predictability, satisfying, efficiency, and trustworthiness for the different kinds of tools. And then Anna used radar plots to try to get a sense of how people trade off these different characteristics. So you can see here for the radar plots for copy, cut and paste, and textual search, what's really interesting is that developers do not perceive these tools. They do not perceive their need for these tools to be satisfying. So they actually aren't looking for, in a sense, completeness of these tools. They're looking for tools instead that are super effective and efficient to use when they're doing these operations. On the other hand, when you look at simple and complex refactoring tools, you start to see a different kind of nature come out of what developers want. And I should point out that there's slightly different scales on all of these diagrams, so be careful to infer too much at a glance. But you can see that for compiler output, developers really obviously want those tools to be trustworthy. That's kind of reassuring because I think we all expect our compilers to be trustworthy. If you look at the one second from the right, simple refactoring tools, they're not quite as concerned about them being trustworthy, but they really want them to be efficient. And they want them to be more satisfying in their use than was true for copy, cut and paste, and textual search. If we look at simple refactoring tools against complex refactoring tools, it's interesting that when it's complex, it doesn't have to be as trustworthy as when it's simple, and doesn't need to be quite as predictable as we thought maybe they could be. So we're just in the beginning steps of trying to understand how to take some of these trade-offs and really start to move them through into tool design. But I think they're an interesting way for tool designers to start thinking about the interfaces that they provide to their tools and to try to understand from developers what they actually want. So what did we learn about sort of usability and usefulness of refactoring tools out of all these studies? Well, I think we came out with themes of knowledge about what developers actually wanted that might be different than what happens when you're studying the use at the moment. And we were able to understand some of these trade-offs that have led us to propose a refined theory for the usability of refactoring tools. And one thing you can note is this theory keeps getting bigger. But in a sense, that's good, because I think we understand more about what developers are actually seeking from these tools when we start to be able to expand upon the theory of use. So that was a little bit about the front part of this pipeline in the context of what Anna was doing. And I will say a little bit about how she took this and has proposed a tool now that she's prototyped for changing how refactoring tools work. So this is showing how the study of the context of use can feed into building a tool. And so she's proposed what she calls stepwise refactoring tools. And the difference with these tools is to try to fit better into all those strategies that developers were using and the characteristics that they were hoping from the tools. So let me walk you through this one screenshot. She has some videos you can look up for how the tool actually works in practice. Down at the bottom of the screen, you'll see in the behind window, the code window, that there's a refactoring that a developer wishes to do on this particular piece of code, which is actually start to remove a parameter. So originally the code had a toggle parameter that showed in the overlay. The developer has simply edited the code to remove it. This pop-up has appeared and it shows you the change that is happening to the code. And it shows you the impact of that change. So it runs the refactoring tool in the background essentially, and it shows you that the parameter, is used in a body somewhere else. It collides with another method, etc. And then it shows you the files in which this occurs. You can then do several things. You can apply everything, which works exactly like an existing refactoring tool, or you can do this step through selected approach, which steps you through the refactoring one by one, so that especially those developers that like to understand local impact could go through and decide which pieces of the code that they actually want the refactoring to apply for. And in this way, you can give the developers more knowledge of the change. The tool becomes more predictable. The tool can also become more trustworthy because the developers see the actual change that's going to occur. So this is trying to balance a bit of the automated characteristics and benefits of systematic change with giving people an ability to understand what's changing and to actually control the impact. Because like a debugger, it would allow you to skip applying a step and continue to move forward in the code. So we haven't gone to the point of actually studying this in use. We've just looked at it against characteristics and made sure it's had the characteristics we've seen from study. But that's an interesting avenue to be done in the future, is to now take that tool and say, what actually happens if we give developers this tool? Does it actually address the issues that they have? So I think there's lots of opportunities to not only do this kind of study for refactoring tools, but to start looking at other kinds of tools like diff and other common tools developers use to see how we can actually make their usage easier and actually do more good for developers. So that's kind of the first part. I wanted to talk a little bit about the second part of the pipeline, in which one might be able to get to larger scale use by actually deploying a tool and seeing how it works. And the best way that I know to do that is to kind of reflect on some of the experiences we've had in moving from having done some of that initial study and building an open source tool, and then taking that into commercial usage in a deployment sense and continuing to study and evolve the tool. So again, joint work with Mick. We've collaborated now for, I hate to say it, something like 25 years, and it's always a joy. And so much of what I'm going to say is really his good work and my colleagues at TaskTop. To give you a sense of the story, in case you haven't had to suffer through one of my other talks on it, what we did is Mick, for his PhD thesis, studied how he could make developers more efficient in working in an IDE by making tasks explicit. He encoded that into a tool called Mylar that provided a degree of interest in the information you were interested in the IDE, and could scope the information that was visible per task and allow you to easily retrieve that. That tool ended up being kind of popular within the Eclipse ecosystem. This was back in 2010 or so. It was deployed as part of the default downloads for the Java parts of Eclipse, which gave it a lot of visibility, which meant we had to talk to a lot of trademark lawyers in New York, because the Eclipse Foundation was worried about our use of the name Mylar. And so we ended up having to rename the tool to Mylan. So Mylan became the rename of Mylar. And at the same time, we spun out a company that was building closed source components on top of the Mylan open source system. So our first business model back in 2007 was to sell directly to developers at a price point developers might pay for their own productivity and use as part of Eclipse. We quickly learned, well, maybe not so quickly, because it took us about 4 years to pivot. We had some success doing that and selling enterprise-wide to development organizations. But in working with our customers, it became really, really clear that they didn't want to install things on each developer's desktop. They wanted to have something the organization could control. So we pivoted to a server version of the tool that, instead of helping the developer only on their workstation, actually help the communication paths between developers. And then we kept learning from our customers each and every year. And now that has become a set of value stream management tools to help give visibility to developers and organizations about the flow of value in their software development. So if you think about this kind of progression, all along it, both when it was open source and in academia, and as we moved into the commercial setting, we have always been studying the tool in the context of use. In the early days, we were doing field studies and monitoring developers' workstations when they were using the academic version of the tool. And now, when it's more in the customer vein, it means a lot of customer interaction, understanding where they find friction in the tool, understanding where they would require more in the tool for them to, say, purchase the tool. So it continues to be a case where you have to pay attention to that user base and how they're using it, no matter whether you're deploying in open source or whether you're deploying in a combination of open and closed source. Most of the TaskTalk tools are now predominantly closed source, relying on a supply chain of open source tools. And so it never really goes away, right? This need to study tools in the context of their use does not go away. It's interesting that most commercial organizations just understand that, right? Microsoft has understood this for a long time. IBM has understood this for a long time, et cetera, et cetera. And yet in research, we kind of just don't do that piece of it. And so that's my appeal to try to get people to do more in thinking about what happens when you deploy a tool, what happens when customers really use it, and what happens when you can start to change what you think the problem is based on what you're learning. So continual attention to the context of use is just really key as you try to make tools, I think, that go through this pathway. So in summary, quick shout out to Anna, who's defending her thesis next Wednesday, which is very exciting. And Mick, this was originally a talk given to ICSME, so definitely like the fact that they caused me to try to make this talk. But also, all of this builds on too many fantastic students I've had the privilege to work with, and just absolutely wonderful colleagues at TaskTalk. So what do I hope you take away from this talk? Well, we've given software developers a heck of a lot of tools. If you look in an integrated development environment, there's a lot of commands, there's a lot of tools there. If you study people when they're working, they learn a certain number of those tools, and then they kind of plateau and they don't learn new tools. Why don't they learn the new tools? We know it's because they don't know that they exist sometimes, but I contend that it's also because the tools don't necessarily work well for them, so nobody's going to tell them to use them. If we start to think about this context of use, start to get a little bit more crisp about what it means to attend to usefulness and usability of tools, I think we can help bridge that gap, and we can get more of the great ideas in research and research tools to start bridging the gap over into deployment and use. But we do have to pay attention to context of use. So that means we have to value in our communities the study of tools and use, and not just the introduction of new tools. And we have to encourage and provide ways for our colleagues in industry to continue to study how those tools are used as they're put out there into the ecosystem. There's lots of questions that this kind of viewpoint, I think, drives for research. You know, you start to think about, are there ways to define what the usage contexts are? Are there kind of just common, is there a common taxonomy of usage contexts that we could start to build up and rely upon? Are there a right number of tools that developers should have at their beck and call? Are we trying to put too many tools into their hands? Are we not putting enough tools into their hands? How can we make our tools fit themselves into the usage context? Not just in terms of is somebody a beginner or an expert, but literally, what does the tool need to do so that somebody finds it as a regular part of their workflow? And that tools, the phrase I like to use is that the tools are working for the developer instead of the developer working for the tools. And then how do we do these experiments so we can auto-collect ongoing usage information that actually lets us look at more than the invocation of use to study forward? So that's what I wanted to talk about a little bit about today. To go back to the summary slide, I think it's all about how do we do more study of the context of use, which requires us to be a little bit more crisp about these terms of usability and usefulness. When we do the study, there are impactful research opportunities that we can study, publish, contribute to the literature. And when we do it, we start to increase that probability, the likelihood that we can take some of these tools and actually get them into use so that we can do that sort of continuum from interesting research insight into actual change of software development. And with that, let me stop and happy to take any questions. I will stop sharing for the moment so I see everybody again.
Thank you very much. This was fascinating. I have questions, but I would like to take questions from our numerous audience. So if you have a question, if you could please raise your hand so I can see you, and then I will give you. Zandra, go ahead.
Hello. Thank you so much, Gail, for your presentation. I'm not from computer science, so it was amazing to understand something. But my question is about the developer, him herself, because the way you show things about usability, and it was an individual way to talk about tools. And I was wondering if there, you know, you talked about context and all that stuff, but I was wondering, when you are part of a group, if you do not legitimize the tools that might be used, instead of thinking about, you know, usability, because you take for granted that that's the way it should be. So your thoughts about that, the group, the team makes a difference when you are talking about that?
So that's a great question. Just out of curiosity, if you're not a computer scientist, what's your field of study?
Marketing.
Oh, cool. Okay.
Knowledge transfer and co-creation.
Excellent. So I guess I think about your question maybe in two ways. And maybe in thinking about it two ways, maybe I'll get close to what you actually mean. So one thing that we have not studied at all, we've really been focused on the individual developer in a lot of this work, kind of in the lab setting. And I think in doing that, we haven't even given any thought yet to how do people approach group tools, right? So something like Slack, right? How does the usability of Slack, the tool, change because there's multiple people using it, and sort of those group aspects? So I think that would be a fantastic area of study, is to start thinking about what do group tools look like when you talk about the context of use. And I think the problem gets even more hairy and more difficult, but really interesting to think about. And then the second part is, how much are you affected by the tools that you use because you're part of a team, right? And I think this is a huge impact. Occasionally I get the opportunity to talk to industrial developers, and I gave a talk at T-Mobile a couple of weeks ago, which was awesome because there was like 200 T-Mobile developers listening in. And the interesting thing about talking to those audiences is that they are really caught into their tool sets, right? They're kind of told that they have to use X or Y, and changing the tools is either at least a group decision or it's an organizational change, because you actually have to go through a formal process in order to use a new kind of tool. And I think this tension makes it really difficult to give developers as a team the best tools to use, right? Because there's a lot of friction in tool change. And so the more that you start to talk about tools that impact something beyond an individual choice, the more that you have to pay attention to the social context in which the tools are used and put into place in order to make any change. What's really interesting is that a lot of organizations are now starting to be more interested in productivity and in the ability to have tool choices made closer to the teams. Because there's, I think, a growing understanding of some of Peter Drucker's work in that, which says you got to empower the workers in order to let them bring their productivity out. But since in software development, we have no idea of actually how to measure productivity, this is kind of a challenge. So I think what I've always liked about software development is it's a microcosm of knowledge work in general that's way more structured. So people tend to use the same tool sets. They tend to work in more of a structured way. And so it allows us to start thinking about sort of the general work of knowledge work in a microcosm that allows us an easier to study group. So I think there's just, really interesting cross-disciplinary capabilities to study some of the interesting questions, maybe from marketing and other areas in using software developers. So I hope that got a little bit to your question.
Totally. Thank you so much.
Great. Next, we have a question from Abdel.
Well, thank you. It was a very, very interesting presentation. Well, I was a software developer in the past and did a lot of refactoring. Personally, I did not use specific refactoring tools, but I used to use a native plugin function of the IDE to do that. And my point is that as technical lead, I never authorize refactoring without having a test suite. You said in your presentation that some people do some planning before refactoring. Is that planning or some checks, for example, if we can start refactoring? So can I have more information about this type of planning?
Yeah, that's a good question. So some of the planning, some people that used a structured strategy would approach the change task and spend a fair bit of time exploring the code before they went about the change. So they would get quite a wide scope of building up what I would call a mental model of how the code worked before they would start to actually change any piece of code. And so is that planning in support of refactoring? I would say it enables refactoring, because as they did that planning, they were able to say, wow, I think I might be able to do this kind of operation of refactoring and get the impact that I want. The folks that didn't do that sort of step of looking at the whole code, they were working more locally or in an execute fashion. they had less opportunity in general to use a refactoring because they never got to even see that it was a refactoring, frankly, or that it could map to a refactoring operation. They were just so focused on the changes in reacting to the compiler output. And so it's not that one strategy is better or worse, it's that the strategy that you take impacts the tools that can apply to your context. And so that's where there ends up being, I think, sometimes a mismatch between the tools that we provide and the and what people can actually even imagine invoking, if that makes any sense.
Okay, thank you. Well, in my experience, I remember that I did some measures. So I remember I used Matrix Eclipse plugin, so I get some measures, and from the result I had, I start to prioritize the refactoring to do, and as I told, I check also before if there is any test suite or something like that, so I can start. Otherwise, it was never authorized. So thank you. Yes, it answered my question. Very interesting. Thank you again.
Thanks.
Thank you. Just so that people know, I have Rizlan, then Harold, then Radwan. Okay, Rizlan, go ahead.
I'm sorry, my question was asked by Zandra.
Okay.
Surprisingly, I'm from software engineering, but my question was about social and Jesus. Thanks. Thanks, Gail. It's very enlightening as a talk. Thank you.
Gail, it's one of our pride points that our lab has actually people from software engineering, marketing, communication, business administration, even though we are mostly computer science. That's part of the mix. So next question is Harold, please.
I got a quick observation and then the question. I really love your idea of the stepwise refactoring tools, because one experience that I remember was that refactoring tools, like the early ones in Eclipse, did have, or reasonably early ones in Eclipse, did have previews. And so you'd get to see what you were going to do. And because of my general lack of trust and desire for control, I would often look at the preview if it wasn't a simple refactoring. And I'd go through and I'd be pretty happy. And I'd see something and say, oh no, I don't want it to do that. And then I'd have to cancel the whole thing because I couldn't be selective about it. And so I was back to doing the whole thing manually. So this idea of being able to selectively pick what you want to do, I think is really great. The question is, a lot of the industrial developers I dealt with were very keen on use cases. And if they were doing tool building, they would insist on having a whole collection of use cases first and then try to build the tool to satisfy them, which we sometimes found frustrating because we had an interesting idea we wanted to just try. But it seems there must be a relationship between a decent set of use cases and the use context that you're talking about. So I wonder if you have something to say about that and how you try to come up with and document use context.
Yeah, great question. Just on the previews, I think that is exactly what we saw people do, right? They look through the preview and sometimes they go, yeah, that looks good, and they'd hit it. And then they go, no, that's not what I wanted the code to do. Can I undo it, right? And you usually can't undo. And so they would then back out, go back and get the original version back and try again. The other thing that previews were hard for people is that when they show you that there's going to be an impact, they don't show you enough of the context of the impact to know whether or not it's the impact you want. And so that's why kind of stepping through within the code might provide some help. In terms of like use cases versus usage contexts, not knowing what the use cases look like for the developers you were working with, my sense is that those folks who are developing the tools, their use cases are still fairly narrow, right? So they already presume somebody knows they want to do a refactoring. They're going to want an ability to control some impact. So we'll do that through one preview. And then they want to get it over with as quickly as possible. And I think that the presumptions that people make in the use case just don't go farther back in terms of the overall, how do people approach their work? And until we kind of broaden that out, we're stuck in this presumptive nature of thinking that we know when the tools will be used. And so I think that there's just likely a mismatch there where we have to broaden out and say, how do people actually go about doing a change task? And surprisingly, when you look through the literature, there's actually not that much about that, even though that's what developers do every day.
Right.
And so somehow we have to get our minds around thinking about how to characterize a little bit better, how especially really good developers do it, and then maybe we could even teach other people how to go about it. I do think that there's opportunities for teaching the people that were very local impact oriented into thinking, let's say, maybe sometimes a structured approach would be good. Maybe they've never seen that. And so maybe we have to do more to let people know about the different strategies, for instance, that can be used.
Thanks.
Excellent. Radwan?
Hi, Gail. Thanks again for the presentation. It was very interesting. Just gonna go quick. It's another aspect probably that you probably covered or not, is the relationship between the level of comfort. And I know you talked about the loss of knowledge in the process of picking up the tool and from the developers. Were you able to measure the level of comfort while choosing the strategy using the tool, and how this strategy impacts actually the desired productivity? That was actually the reason why we use refactoring, meaning in avoiding rework. Actually, and when we compare doing refactoring or using refactoring tools with your own work or others' code, so were you able to measure such impact of a level of comfort?
No, I don't think we got a sense of level of comfort as much. I will say that, even though we sort of show one strategy per participant per task, they often did try different strategies, and we picked up the dominant strategy that ended up working with them. So we did have folks who, might try an execute strategy, and then they would actually default back to actually trying a structured strategy. So if you look through the videos, which I think they're in a public data set, you can kind of see some restarts of different approaches that they used. So in terms of sort of the level of comfort, what we saw that come through more is in terms of the characteristics they would describe. So if you look through the transcripts, they're kind of funny after a while because people will try a refactoring tool and they'll go, you'll literally see them because it's a verbatim transcript, modulo any, bad words, where they'll say like, I can't believe that just happened, like, or what happened? And so you can see places where they could not anticipate what the tool did. And that is a problem for a tool, right? I think that predictability is probably a pretty important thing for a tool. Or you would see them check whether what they thought would be true of the tool working was actually true. So let me run the refactoring tool. Now let me do git diff and see if it actually did what I think it did, which is also a sign of sort of not trusting the tool. And I think there's some developers who are quite willing to just trust. And there's some developers who are not going to trust the tool at any cost. The only tools they really seem to trust are their compiling. Thankfully.
Thank you.
Great. Are there any other questions? Okay, I have a question. Okay, Rizlan, go ahead.
So as I missed the opportunity to ask my question earlier, I'm coming back with another question, which is very, I would say, naive, because maybe it's the notion of predictability that I don't get really. Yes, it's part of the usability, but somehow I can see it as part of also the reliability of the tool, of what the tool is doing, its correctness at the end. So is it's kind of confusing in my mind. So I'm seeing predictability as part of the reliability of the tool. Like the tool is doing exactly what it is meant to do. So can you elaborate on that? Because I was thinking of usability as some cherry on the top. So the tool is already doing what I'm expecting. Now, is it easy to use for me? Is it intuitive? That's the kind of question I have in mind. Thank you.
It's not a naive question at all. We struggled a lot with some of the definitions of these characteristics. And so what we used for predictability was the user understands upfront what will happen by using the tool, or indicates a lack of surprise when using the tool. So the tool has a specification, right? Let me try and explain what I think we mean by this. The tool has a specification. The tool, we would expect the tool behaves according to its specification. But what the user understands the specification to be, and what the specification is from the tool, might have a gap. And that's where sort of predictability comes in, is if you think about the user approaching the tool, what does the user predict will happen when using the tool, which can be different than the sort of formal definition of what the tool can actually do within the programming language. And so that gap is what causes the surprise often that you see developers utter, because they're like, I thought the tool should do X, and they're not going to go read the specification of the tool, right? And in fact, the tool did not do X. So, you can sometimes see this, I think, when you teach students, right? Which is they express surprise when the compiler didn't tell them about a kind of error. Why did the compiler not tell me I was going to have a buffer overflow? Compiler can't do that, right?
Yes.
So that's my best suggestion of where that kind of comes in.
Thank you.
One of the things I noticed, I don't code assiduously right now, so I don't have a recent experience, but one of the problems I remember having with the refactoring tools within the Eclipse environment is actually the preview tool does just one step. So it tells you the immediate impact, but then if you actually accept some of the changes, then it calls itself recursively, and then the next changes will have some other impacts. And so I guess that's one of the reasons why when it looks too complicated, I didn't trust it, because like you said, I might get stuck in a rabbit hole and then I don't know how to back out. And so I did a better integration maybe with the source code management tools that would allow me to do one bulk set of changes and then or roll them back. But I don't have a solution. I can't think of an easy solution for how to propagate that. So anyway, what are your thoughts about that?
Yeah, well, I think you've hit like sort of the nail on the head, right? To use a tool analogy. What's interesting is, and I guess why I found studying refactoring tools kind of interesting, is that Bill Griswold was leaving UW with the same advisor just when I was starting. So, I was reading Bill's thesis as part of, what is a PhD thesis? And it's such a seductive thing, right? We do these operations. It can take care of all the ramifications for you. This is obviously only a good thing to have refactorings. And rename is a great example. I mean, I love the rename refactoring when the few times I ever get a chance to program anymore, which is like really not very often. On the other hand, when you start to get into the more complex refactorings, now you start to get into places where, you might think that you know what you want it to do, but you're not quite sure. And in fact, the refactoring tools now allow you to unselect some of those parts, right, of the refactoring. So that seductive part that will take care of all of the ramifications for you, you now get to control, which is a good thing. but now it's no longer the same thing. And so we talk about all of this range of tools as one thing, automated refactoring, but frankly, you know, it's a range of very separate tools. I don't think that we're very good at kind of explaining those tools even to the students we teach, right? Not just refactoring, but the compiler example I gave you. The really smart students go, oh yeah, I get it. Static structure, they can do this. Compilers can do this. They can't do that. But I would say the vast majority of at least the students that come out of our program, lots of them don't understand those boundaries. And that makes it really difficult to start introducing sophisticated tools to them later on.
Thank you very much. Hamid.
Thank you, Gail, for your presentation. Very interesting. I am also a student of Dr. Millie, working on aspect-oriented programming, subject-oriented programming, and the view-oriented programming.
Ex-student.
My question, not now, sure. 20 years ago. My question is about context. How you handle the context of user? Did you model the context of users, or do you have some details how you handle the context?
You know, that's still work to do. I think the community needs to do. We don't have a good sense of being able to describe the context of use. We did do one piece of analysis on the data that we had from the study of 17 developers, where we kind of created summary descriptions of what they did and the tasks and how they approached it. And I think that starts to get maybe towards the usage cases that Harold was referring to, as you start to try to bridge that gap of what was actually going on. It turns out it's really hard to describe what developers do if it's not just right at the moment. So how do you kind of, you know, start teasing apart what is actually the usage context? Does it matter what their team was? Does it matter, you know, what programs that they had loaded? Does it matter what the kind of software is? Does it matter if high reliability is important for the domain of the software? I think these are all things that we have to start getting a handle on. And so we had chosen very specific tasks. They weren't very big. They were individual tasks. And so our context of use is really limited. So I think that's work to be done.
Thank you.
Harold, is that a new hand?
Should unmute before I respond. Yes, it's my other hand if we have time.
Oh, sure, we do. Go ahead.
I've been puzzling in the background a little bit about the distinction between the local strategy, especially as expressed in terms of go to where the compiler indicates problems or errors and examine it, and the structure one. Because of course, if you delete a parameter or something, the compiler is doing a structural thing to highlight the local pieces. My guess is that what you're getting at here is the mindset. You know, of the individual, whether the programmer is keeping the whole structure in mind or whether the programmer is very locally focused. That maybe I wonder if that ties into the personality of the developer in some interesting way.
I think it does. You know, in some other studies, we've actually done the personality trait assessments, and it's hard to get a signal out of those, frankly. But I think you've described it accurately, right? It's about, the strategy is about what the user brings to the task instead of what the task is like or what the tools are doing. And a lot of the work that we do in software engineering, we focus on the artifacts and the tools, and we don't actually focus on the people who use them. And so this is trying to kind of bring the context, bad word. This is trying to bring the perspective of the developer and what they're thinking and the cognitive load that they take on. So the structure strategy people take on the cognitive load themselves. I'm going to do these queries, and I'm going to build a model in my head, right? The local people go, I don't want to carry that stuff around. I'm going to deal with it one by one and let the tools guide me through that process. Right. The problem, as we all know, is sometimes you go down a rabbit hole that way, and you've done like 20 changes and you're like, actually, these changes don't make any sense. So now I have to go all the way back.
Yeah.
This is what I miss about conversations with people in real life, with people like Harold and all of you, is getting those kinds of insights as well.
Yes, that's the real fun part of research.
Chris.
Hi, Gail. Thanks for the talk. I had a question more about the testing, because one of the strategies was more like Martin Fowler's approach of saying I have to run all my tests after every refactoring. I mean, if you read his book, he will basically say you can't do refactoring unless you have tests that you run at each step. And that's kind of a philosophy. But in your experiment, were there tests? I'm assuming there were tests for people to run, or did you look at the culture of tests of the individuals, that kind of dimension?
Yeah, there were tests to run, and that's where those execute strategy people really relied on the tests. In one of the examples, there was like the removal of an overloaded method. And that's where things get a little wonky when you start to use refactoring tools, because you can end up taking out parts of tests that you still actually might want to have. And so the impact on the tests is harder to determine whether you still have the test suite that you wanted. And that's where people got a little worried about the refactoring tools and the execute strategy, where they were like, hold it, don't touch my tests, right? And if they had used the preview view appropriately, they could have figured that out, right? They could have undone those refactorings. But cognitively, again, they were thinking about, I have my code and I have my tests. And I just want to say, apply the refactoring to my code, not my tests. And yet they start looking at a preview view and they're like, okay, well, I'm worried about the refactoring. Now I have to worry about the test versus the code. And we kind of conflate in the tool, you know, too many cognitive concepts for them to tailor apart. But there were definitely people that were very stringent about, I'm going to rely on the tests. I want the tests to run. I'm assuming the test suite is good, and go from there.
Excellent. So see if there are any questions. I think we should probably, so Gail probably has a busy day as a vice president of research. I can't imagine what your days look like. So I don't know if there are any questions.
Maybe I can just add a comment. One of my students actually started a systematic review on existing studies on mobile development frameworks. And one of the interesting findings we have till now is that most of the studies didn't ask or carry out any studies with developers, with end users who are developers. And that was very surprising. So when it comes to tools used by developers, it's like we ignore the end user a bit. They all use some methodologies based on some quality attributes that they checked themselves, the authors generally, and they didn't really try to give just the framework to some developer and try to see how it is used in his context. So it's interesting. So what you presented today gave me some insights, interesting insights on that.
Well, and to be fair to everyone, right? I mean, I feel lucky to be in Canada and in a place where, you know, I think I've been lucky to be judged on quality instead of quantity. And in a lot of places in the world, right, you know, students are really pressured to have a lot of publications, and doing these studies is really time consuming.
Expensive, yeah.
And hard.
Yeah.
And I think we have to value them a lot more.
Yeah.
Because it's, you know, it takes months and months. It's not what Anna was expecting to do. She ended up being really interested to do it, and it ended up being, you know, a huge part of her thesis. But it's challenging to get the people to participate. It's hard to analyze. So I totally understand why there isn't more done, because I don't think we value it enough.
Yeah, yeah, thanks.
Yeah. So I think we're going to have to leave it at that. Gail, thank you very, very, very much for taking the time to talk to us. Just a little anecdotal evidence. I'm sure you're used to large audiences, but you have had the largest audience of our seminar, which is not, you know, but the key point is, and your talk doesn't even have the word machine learning in it. So that's a tremendous exploit.
Thanks for the invitation. It's always, a pleasure to get to interact with folks, and virtual is great in a sense because it's so much easier to make it happen. So thanks so much for
Great.
inviting me, and let's keep in touch.
All right, great. Thank you very much.
you.
Thank you, everyone.
Thank you.
Have a safe season.
This has
Bye-bye.
been